Hello everyone, I am Shankha Subra Sanyal and I welcome you all on behalf of S-Cube's classes. Well, I'm really thankful to all of you for your overwhelming response. The amount of love that you have shown through your mails, through your feedbacks, I'm really grateful. I'm really privileged. Well, let us talk about real numbers in this lecture. What is a real number? A number whose square is non-negative is called a real number. In fact, all rational and all irrational numbers form the collection of all real numbers. Every real number is either rational or irrational. Consider a real number. If it is an integer or it has a terminating or repeating decimal representation, then it is rational. If it is a non-terminating and non-repeating decimal representation, then it is irrational. The totality of rationals and irrationals form the collection of all real numbers. First, we are going to discuss about completeness property. Now, what is this? On the number line, each point corresponds to a unique real number, and every real number can be represented by a unique point on the real line. There is another property which is known as the density property. What is that? Between any two real numbers, there exist infinitely many real numbers. This is known as the density property. Let's talk about the addition properties of real number. There are closure property, associative law, we have commutative law, the existence of additive identity and existence of additive inverse. Let's have a look. What is the closure property? The sum of two real numbers is always a real number. This is the closure property. What is an associative law? It says that if there are three numbers A, B and C, then A plus B plus C is equal to A plus B plus C, where A, B and C are all real numbers. Taking the discussion forward, we have commutative law. What is that? It says if A plus B is equal to B plus A, it holds good for real numbers. Existence of additive identity. 0 is a real number. So 0 plus A is equal to A plus 0, which is again equal to A for any real number A. So 0 is called the additive identity for real numbers. For each real number A, there exists a real number minus A, such that A plus minus A is minus A plus A, and the sum is coming to be 0. Thus, A and minus A are called additive inverse or negative of each other. This is basically the additive inverse property. Similar to addition of two real numbers, for multiplication of two real numbers, we have the multiplication properties. Again, over here we have closure property, which says the product of two real numbers is always a real number. What is the associative law? It says the product of AB when multiplied with C, that must be equal to the product of BC multiplied with A. The commutative law says AB, the product of AB must be equal to the product of BA, where A, B, C, whatever we are discussing over here are all real numbers. Like the existence of additive identity, over here we have the existence of multiplicative identity. What is this? 1 is again a real number. Now, if I multiply 1 to a or a to 1, in either of the cases, the product will be a only, which is again a real number. So 1 is called the multiplicative identity for real numbers. There exists a multiplicative inverse as well. For each non-zero real number a, there exists a real number 1 by a. What do I mean by this? I actually mean if I multiply a with 1 by a or 1 by a with a, in either of the cases we'll be getting the result to be 1. Thus, a and 1 by a are called multiplicative inverse, or more commonly we call it as reciprocal of each other. The distributive law of multiplication over addition, it says the sum of b and c, that is b plus c, when it is multiplied with a, the result is ab plus ac. That means if a plus b is multiplied with c, the result is ac plus bc. Here, all real numbers a, b, c have been considered. There are certain important results. For all positive real numbers a and b, we have root over ab to be root over a into root over b, while root over a by b is nothing but root over a by root over b. Let's take a problem 3 root 2 plus 7 root 3 and root 2 minus 5 root 3. We had been asked to find the sum. We have to add them. So on addition, what we'll be doing? We'll be adding the like terms together. So we have 3 root 2 plus root 2, which comes to 4 root 2. While 7 root 3 minus 5 root 3 is nothing but it is 2 root 3. If we are asked to multiply 5 root 11 by 3 root 11, over here, since both the terms under the root is 11, we can actually multiply by the terms which are outside the root, 5 and 3, and we'll get 15. While if I multiply both the roots 11, I'll be getting root 11 into root 11 is nothing but 11. The root goes off. So the result is 165. Let's take another example. If I'm asked to divide 15 root 15 by 3 root 5, what do I find? 3 and 15 may be cancelled out. So we'll be left with 5. But as one of the properties we have discussed, root 15 can be written as root 5 into root 3, and we have root 5 in the denominator. So they will be cancelling each other, and the result that we'll be getting is 5 root 3. We had been given 4 sums which we need to solve. We are asked to simplify them. We have products of various numbers given over here. Let's take one by one. The first one says 3 plus root 3 into 2 plus root 2. We'll simply go by expanding and multiplying. What we get? We'll be getting, as you can see on the screen, 6 plus 3 root 2 plus 2 root 3 plus root 6. Now, how did I get root 6? By multiplying root 3 into root 2. Similarly, for the second question, what do I have? I have 6 plus root 6 into 6 minus root 6. Isn't it in the form a plus b into a minus b? So I can easily write down it to be a square minus b square. That is 6 square minus root 6 square. So 36 minus 6, the difference is 30. Let's take the third question. It's root 3 plus root 2 whole square. Now, isn't it in the form a plus b whole square? So what is the formula for a plus b whole square? A square plus b square plus twice ab. So on applying, we get root 3 square plus root 2 square plus 2 into root 3 into root 2. So the answer that we get is 5 plus 2 root 6. Coming to the fourth one, it is root 5 minus root 2 into root 5 plus root 2. Again, this is in the form a minus b into a plus b. So the answer would be, it would be nothing but a square minus b square. So what we get? We get 5 minus 2, which is equal to 3. Let's check with this question. We had been asked to simplify root 72 by 5 root 72 plus 3 into root 288 minus 2 into root 648. This question came in 2014. See, over here, just looking at the question, I know they are all multiples of 72. So let me keep the numerator as it is. What should I do with the denominator? 5 root 72, let it be as it is. Coming to 288, how can that be represented? It can be represented as 4 into 72. Similarly, 648 can be written as 9 into 72. Now see, both 4 and 9 are the square of 2 and 3. So if I take them out of the square root, I simply come down to root 72 by 5 root 72 plus 6 root 72 minus 6 root 72. Now check over here, minus 6 root 72 and 6 root 72 gets cancelled off. I'm left with root 72 by 5 root 72. Again, root 72 from numerator and denominator gets cancelled, and what are we left with? We are left with 1 by 5. Let's take this question given on your screen. We had been asked to simplify. So what do we get? We get a square minus b square under root plus a by a square plus b square under root plus b to be divided by a square plus b square under root minus b by a minus a square minus b square under root. On simplification as shown on the screen, what do we get? We get a square minus root over a square minus b square whole square divided by root over a square minus b square whole square minus b square. If we simplify them, after cancelling off, we'd be getting b square by a square to be as the answer. So this brings us to the end of the lecture. Well, before I sign off, as I always do, I would request you, in case you have any queries, please do feel free to write to me at scubesclasses@gmail.com, or you can WhatsApp me on the numbers given on your screen. It would be a privilege on my part to be addressing your queries. Thank you so much.